Recurring decimals. What you do in a recurring decimal question is try and match up things that are going to cancel out. Because these repeat, if you multiply by a power of 10, then you're going to eventually get a situation where what's after the decimal repeats and we can cancel things out. Let's show you what I mean. So let's times 0.03 recurring by 10. I just need to grab myself a pen. So we're going to do 10 times 0.3 recurring, and we get 3.333333 and so on. Remember, 0.3 recurring means 0.3333, and if we times by 10, the decimal place moves one to the right. So it's moved one to the right. This is 10 times as big. Now let's look at one lot of 0.3 recurring. We'll write out some of it. And we can see that after the decimal place, okay, this all matches. So therefore, if we subtract these, all of the decimal stuff after the decimal place is going to cancel and just leave us with a nice number. So one lot away from 10 lots gives us 9 lots. So we've got 9 times 0.3 recurring, and that a 0 away from 3 gives us 3. And all this matches, so there's no more to be taken away. So all that taken away from that leaves us 0. So 9 lots gives us that. So therefore, if we divide by 9, we'll have 1 lot. So divide that by 9, we're just left with 0.3 recurring, and we get 3 over 9 if we divide by 9 on this side, which equals 1/3 when we cancel down. So 0.3 recurring equals 1/3. Now that was quite simple. We only had to times by 10. Let's look at what happens if we do something a little trickier. 0.35 recurring, which with the two dots above the 3 and the 5 means we get 35353535. So let's look at some powers of 10. What I'm going to do is I'm going to start at one lot, and we'll stick with blue. 1 times 0.35 recurring equals 0.353535 and so on. Now let's look at 10 lots, see what happens here. 10 lots of this equals 3.535353. It's quite important to make sure things line up, and we see this doesn't match up. So let's go again. Let's do the next power 10 up. Let's times by 100, move the decimal place one further. So we get 0.35 recurring times by 100 gives us 35.353535. And we can see the 100 one and the 1 one after the decimal place. So after the decimal place here matches up here. They're exactly the same. So we just subtract 353535 away from 353535. I forgot to put the dots in there. And they will cancel. So we're just left with 35 minus 0. So no recurring decimals. So we're going to subtract one lot away from 100 lots. So 1 away from 100 gives us 99 times 0.35 recurring, and that gives us just 0 away from 35 is just 35. So this is 99 lots, so this equals this. So if we divide that by 99, we'll get 1 lot. So 1 lot of 0.35 recurring will equal 35 over 99. Now let's have a look at this one. We're going to convert 0.312 into a fraction. Notice that recurring decimal is only 1, 2. The 3 isn't recurring. So this one's a little bit trickier again. So we just have to be careful. But you just follow the same pattern. Let's just keep timesing by 10 and see when it matches up. So I'm going to start off with, because it's 3 digits, maybe I'm going to start off with 1000. Yeah, because that's times by 10 times by 100 times by 1000. So it seems to be sensible to start off with timesing by 1000. So if we do 1000 times 0.312 and we get 312. Now it's only the 1 2 that reoccurs, so if you move the decimal place here, 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 the next number here is going to be 1. So 0.121212 and so on. Let's do 100 times 0.312 recurring. So we're going to get 31.21221. So let's look at 10 times 0.312 recurring, and we'll get just the 3 this side, so only moving the decimal place one place now. 1 2 1 2 1 2. Now the smart ones amongst you might have spotted what we're going to use, but let's just go right down to 1. If you really don't know, do them all and see where we get to, and we're back to 0.31221 and so on. Oops, gone up to the last question for some reason. Let's come back again. Here we go. Now let's just change the pen colour so we can highlight the things it's saying. Now notice we've got 3 1 2 1 2. Now that doesn't match with anything because there's a 3 at the front. Now here we've got 1 2 1 2 1 2. 2 1 2 1 doesn't work, but again we're back to 1 2 1 2 matching up. So the 2 that we're going to subtract are going to be this one and this one. So if we do 1000 lots minus 10 lots, we get 990 lots times 0.312 recurring. And we do 3 1 2, point all of that, minus 3 lots of that. Well, 312 minus 3 gives you 309. Now what's half the decimal matches up perfectly, so they'll cancel out. So we've got 990 lots equals that, and then we find out what one lot is by dividing by 990. So you get 309 over 990. Now, if you're not very good at cancelling down, what you can do is you can get your graphical calculator in, and you press the fraction button, and you get 309 over 990, and you can press equals and it will cancel down for you. And we can see we got 103, so 3 goes into this 103 times, and we can see 3 goes into this also 330 times, and that cancels down. Now 3 doesn't go into that. This is a quick way to check if 3 goes into a number, because the digits will add up to 3. The digits add up to a number divisible by 3, and these add up to 4, but not divisible by 3, so it's not going to be divisible by 3. It's obviously not 2, 5, 4, 6, because none of those, because of the factors here. 7, you can quickly check. 7 goes into 10 once, and you've got 3 left over, but it doesn't go into 33. 8 won't go there for, 9 won't go for, 10 won't go for, and now you're getting past the square root of 103. So there's no number that goes into that. So therefore there's no factors of 103, so that must be a prime number, so there's no need to cancel down any further. But the calculator did it for us, as we can see. Yeah, the calculator will always give you the best answer. So let's go on to another one where we've got a number at the front, which we've not had yet, and then we've got the dots at either end. Now if the dots are either end, that means all the numbers in between are recurring, but some texts may put the dot in the middle on all the numbers, like so. So therefore it could be either dots at either end or all 3 with dots. You need to appreciate those 2 types of ways of writing it. So let's write this one out. Now again we've got 3 numbers after decimal, so let's start off with 1000 lots of this. Makes sense to move the decimal place right the way through. And of course you've got 3 different numbers, so it's going to take at least 3 moves before anything's likely to match again if you think it through. So you got 5, 3, 1 recurring. You got 1,000 times. You get 1531.531, and it just repeats. If we do 100 times, we get 153.153, and so on. You do 10 times, 1.531 recurring. We'll get 15.315, and so on. And we still haven't got anything matching. How about we do 1 times? Let's hope something matches, otherwise we're going to have to do more timesing. So here we go, we get 1.531, and we see we have a match. We've got a match here, the 531, we've got a match here, the 531, so we're going to take these two away from each other. Let's just slide down, give ourselves some space. So 1 lot away from 1,000 lots is 999 lots times 1.531 recurring. 1 lot away, this 1 point that away from all of that just leaves you 1530. So we're going to divide by 999 to get what 1 lot is, like we have before, and we get 1530 over 999. Again, you can use your calculator to check. So let's just cancel that and put that in, and we get, what was it, 1530, just so you can see how you can use your calculator. This 999 equals, and it does cancel down. So we get 170 over 111. So equals 170 over 111. Now let's just review what it is we do. We multiply by powers of 10, so 10, 100, 1,000, if you need to go 10,000 or so on, until what after the decimal point matches. It's got to be what's after the decimal point matches, because otherwise we will just end up recurring. You could actually have a go at trying one where it doesn't match and see what you get. Again, all of these matched. That's what we did. We just kept timesing until what was after the decimal point matched in all these questions.